Good morning, and today I'm going to talk to you about some vectors. And first I would like to say that cats are not vectors. He's a cat. So, first thing, I want to talk to you about the difference between a vector and a scalar. So let's see what you remember about scalars and vectors. You may or may not remember this stuff. You may or may not have seen this stuff. A scalar, what is a scalar? And if you want to pause in between, that's always good to pause in between. See if you can answer them. So a scalar is a magnitude only, something that only has a magnitude. And you ask, what is a magnitude? So if you want to think about it, pause, and I will tell you that a magnitude is a number with a unit. Like 5 meters. Whoop! 5 meters. Or 90 newtons. Those are magnitudes. So what makes a scalar different from a vector? Well, a vector has that magnitude, this part, but it also has, pause it, also has a direction. And so what is a direction, you might think? Well, pause it if you want to think. A direction is the way a vector points. So maybe I threw the sign 5 meters up, right? So up, I've got the direction pointing up. 5 meters is the length. Maybe there were 90 newtons. I don't know. I don't think I can get this all the way out. I'm going to go up with it. 90 newtons up for a force. Maybe that's how many newtons I had to throw with to get the paper to go up 5 meters. I didn't throw with nearly that much force, but just for the sake of things. What do you notice is different about these? And pause it if you want to think. So a couple things that are different. They're made out of different stuff. They're different colors, but the main thing is they are different lengths and they are drawn to scale. So the 90 Newton vector is, gosh, how many times? 18 times longer than the 5 meter vector. But we couldn't add these together. Any idea why you could not combine those together, 5 meters and 90 newtons? Okay, pause it if you want to think more. Well, they are different units, and you can't add meters and newtons, just like you can't add apples and oranges. So in order to add them together, we need them to all be the same unit. And so if they're the same unit, I think they should be, you know, the same color or the same material, or something needs to be the same. Anyway, so we can add vectors. And I'm going to start with something a little easier than this 91, because that one is really long and it doesn't actually fit on the camera. I'm going to add together 5, and I didn't make a sign for this one, but let's see how long it is. So how long do you think it is? Pause if you want to think longer. 15 meters. So this one's 15. What if we walked north for 15, oops, you can't even see that on the camera, north for 15 meters, and then we walked north for another 5 meters? What is our resultant displacement? How far did we walk in total? And hopefully you paused it or you have an answer. And our resultant displacement, when we add those two together, is going to be 20 meters. Okay, hopefully that one made pretty good sense. What if we walk 15 meters north, and we turn around, and we come back and walk 5 meters south. Think about it, what's the resultant or the equivalent distance there? Sometimes it's called resultant, sometimes equivalent. Well, how far away are you from the beginning point? If you said 10 meters, then you did great. Now normally we don't draw them on top of each other. Normally you're going to draw them like to the side, just so that you can kind of see and tell the difference. And there's one more way we can add vectors. Yes, you subtracted, but it's also called adding vectors. We can add vectors. I'm going to use a bigger, longer one. This one is 45 meters long. It's 3 times as long as this one. And notice I draw, let's see, this one's to the east, and then I'm going to put my second one, like I walked east, and then I walked north, and I connect them. It's called connecting head to tail, but you always draw them that way. Now, how far away are you at the end from where you were at the beginning? Well, I'm going to draw a straight line from the very starting point to the very ending point. And what kind of triangle do we have? What kind of triangle is that? Hopefully you said it's a right triangle, and yes. So what theorem would you use to figure out how long that one is? And hopefully you said Pythagorean, because that is it. A squared plus b squared equals c squared. Remember, this is 45. This one is 15. If you're interested in solving this, pause it real quick. I have the answer, which is 47.4. If you don't know how to do that yet, that is no problem. But if you are a little more advanced, there is a lovely vector problem all solved. That's finding the resultant or the equivalent vector. So this is what's going to happen in the vector section. I'm out of here.